Okay, so today we're going to talk about identifying whether lines are parallel or perpendicular, not just by looking at the lines, but by looking at their equations. And then we're going to write equations for lines that are parallel and perpendicular. Okay, lines that are parallel have the same slope, because if the line is going at the same slope, you've got two lines, they're never going to cross. They're going to be parallel. So if we have these two equations, our slope is 3 in both cases, so those are going to be parallel lines. The difference would be the first line has a y-intercept of 4, the next line has a y-intercept of 5. So we did this a little bit on Desmos yesterday where we slid the lines, if you move the slider, for the y-intercept, but not for the slope. The line stayed exactly the same, it just shifted up or down. That's because those lines would be parallel. Lines that are perpendicular have opposite slopes. So in other words, what that means is that the slope of one line is the negative reciprocal of the other. So it's opposite in sign, and it's opposite by being the negative reciprocal. So if we have a line with a slope of 2/3 and another line with a slope of negative 3/2, those lines are going to be perpendicular to one another. Questions so far? Okay, let's look at an example. This asks, are the following lines parallel, perpendicular, or neither? So we need to know what the slope of each line is, first of all. One of the equations is really easy to find the slope. Which one is easy to find the slope of? Gretchen? The second one. The second one is in slope-intercept form. So the slope is always what's in front of x. And just a reminder, slope-intercept form is y equals mx plus b. Point slope and slope-intercept are the two forms where we can see the slope really easily. So if we want to know the slope of this line, what should I do? Lacey? Good. Divide all of them by 4. We're going to put it in slope-intercept form by getting y by itself. So if I divide everything by 4, I get y equals negative 5/4 x plus 3. So now we can look and pull the slope right out of the equation. So, to answer the question, are these lines parallel? Are they perpendicular, or are they neither? Adam? Perpendicular. Good. The slope of the first line is negative 5/4. The slope of the second line is the negative reciprocal, so they are perpendicular. Okay, let's look at another example. Are the graphs of the equations parallel, perpendicular, or neither? So let's see. Sam, which equation is easy to tell the slope of? The first one, and what is the slope?
3/4.
Good. So for the first equation, the slope is 3/4. What do we need to do to the second equation so that we can find the slope? Lacey? Good. Start by subtracting 4x from both sides so that we get it in slope-intercept form. So we end up with negative 3y equals, I'm going to put the 4x, or the negative 4x first, so that it's in the same form visually. Okay, what would I do next, Katie? Negative 3. Good. So I end up with y equals negative divided by negative is positive. So I have 4/3 x minus 3. So the slope of this line is 4/3. So are these graphs going to be parallel, perpendicular, or neither? Natty, what do you think? Actually, no. Because to be perpendicular, they have to be the negative reciprocal of one another. So this is kind of a trick one. This one the slopes are the reciprocal of one another, but they're not the negative reciprocal of one another. Let's actually look at what these lines would look like quickly. The slope is positive in both cases. That would give you a little bit of a clue. Let me pull up Desmos and we'll actually graph these. Oh, except my internet is down. Let me see if I can fix this quickly. Every day this happens. Here we go. Let's try this again. Desmos. All right, here we go. So I'm going to graph a line that has a slope of 3/4. Okay, it looks like that. And I'm not going to give it any y-intercept for now. I'm just going to graph a basic y-intercept of 0. Now I'm going to graph a line that has a slope of 4/3. So these lines are going, they both have a positive slope. So they're both the kind you have to walk up, not ski down. So they both have a positive slope, but the slope of one is a little bit steeper than the slope of the other. 4/3 has a steeper slope than 3/4. Okay, so they would not connect. Now if I change one to be negative, if I make the 4/3 become negative, then they are now perpendicular to each other. Okay, let's go back to this. Let's take a look at this one. I think we'll keep doing these together since we have a shorter class today. Zane, can you tell me the slope of either of those lines just from looking at them?
The second one, it's negative 1/6.
Good. So the slope of the second line is negative 1/6. What do I need to do to the first line? Rosa? Good. So what do I end up with, Rosa? +1. Good. So are these lines parallel, perpendicular, or neither? TJ? They are parallel because the slope of the first line is negative 1/6. So these would be parallel. And we forgot to write the word neither over here. Okay. This is the typical type of problem that you're going to see. A line passes through a certain point, in this case 12,5, and is parallel to the graph of y equals 2/3 x minus 1. What equation represents the line in slope-intercept form? Okay, so if our line is parallel to the graph of this line, what does its slope have to be? Dan? It has to be 2/3. The slope has to be the same. So now, once we use that piece of information, we're just back to the thing we did before where we were given the slope and a point and we had to write a line. And I gave you a hint. If we have a point and the slope, we want to use point-slope form, right? That's the easiest one to write. And then we can transform that to slope-intercept form. Jocelyn, what would the equation be in point-slope form? What's that? Point slope is y minus y1 equals m times x minus x1. What is m? 2/3, good. Minus 12, good. Okay, so we have our equation in point slope. Now we need to just transform that to slope intercept. I'm just going to go through that quickly. So we have y minus 5. I'm going to distribute equals 2/3 x minus 2/3 times 12. I'm just going to do that over here so some of you can see how that whole fraction thing is working. I'm multiplying times 12 over 1. I'm going to cross simplify. 3 goes into 12. 4 times. 2 times 4 is 8. So I get an answer of minus 8. Adding 5 to both sides gives me y equals 2/3 x minus 3. And that's my answer. Okay, the next slide is another example of a parallel. I'm going to skip, we only have about 4 minutes left. I'm going to skip to one using perpendicular. Okay, so I'm going to skip to here. Write an equation that represents the line that passes through the point 2, 4 and is perpendicular to the graph of y equals 1/3 x minus 1. Emma Lillybridge, if our new line is going to be perpendicular, what would its slope be? Let's see. Hannah. -3. It needs to be the negative reciprocal of this, so it would need to be -3. So we're going to need a slope of -3, and our point is 2, 4. So what kind of equation would be best for me to write? Sam. Easiest for me to write. Point slope, good. And what would that be? Good. This one's nice because there's no fractions. So y minus 4 equals -3x plus 6. Adding 4 to both sides gives us y equals -3x plus 10. Okay, your assignment is page 334. Let's just do 7 through 23 odd. That's going to give you all of them. Since we have no class time to work, we'll do 7 through 23 odd. And also, if you did not submit that Canvas assignment, give it another try today. I wish we had some more class time actually, so I could look at that with you. But make it a try. Yes.
Control O and do that.